Hey everyone, and welcome back to the channel. Today, we're diving deep into the ocean to uncover the story of one of its most acrobatic and fascinating inhabitants, the flying fish. These aren't just fish that jump. They are masters of the air and sea, and their story is an incredible saga of evolution, adaptation, and survival. So, buckle up as we explore how these amazing creatures learn to fly. Flying fish belong to a family called Exocoetidae, with about 64 different species found soaring over the warm, tropical waters of the Atlantic, Pacific, and Indian Oceans. For centuries, sailors and seagoers have been mesmerized by their ability to burst from the water and glide effortlessly above the waves. But let's be clear, they don't fly like birds, flapping their wings. Instead, they've perfected the art of gliding, a skill that sets them apart from almost every other fish in the sea. This isn't just a neat party trick. It's a life-saving evolutionary masterpiece born from the constant danger of the open ocean. So, why did flying fish evolve this incredible ability? The answer lies in one powerful driving force: predation. In the vast expanse of the ocean, there's nowhere to hide. For a small fish, you're constantly on a menu for bigger, faster predators like tuna, marlin, and dolphins. Imagine being chased by a predator that's faster and stronger than you. Your options are limited. Most fish would try to dive deeper or dart away, but flying fish came up with a brilliant, out-of-the-box solution: leave the water entirely. To do this, they evolved a set of remarkable adaptations. First, their bodies are shaped like a torpedo, sleek, streamlined, and built for speed. This allows them to build up incredible velocity underwater, racing towards the surface at speeds of up to 60 kilometers per hour. As they break through the surface, they spread their dramatically elongated pectoral fins, which act just like the wings of a glider. These fins are huge in proportion to their body size, providing the lift they need to stay airborne. But that's not all. Their tail, or caudal fin, has a larger, more powerful lower lobe. As they are about to launch, they rapidly beat this lower lobe in the water, like a propeller, giving them that final powerful thrust to lift off. Once airborne, they can glide for astonishing distances. The average glide is about 50 meters, but there have been confirmed records of flying fish gliding for over 200 meters, that's the length of 2 football fields. Sometimes, they can even chain these glides together, touching the water's surface with their tail to gain more speed and launch back into the air, extending their flight time for up to 45 seconds. For a predator chasing them underwater, it's as if their prey has simply vanished into thin air. It has a genius escape plan that gives them a crucial advantage in the daily struggle for survival. The story of the flying fish didn't happen overnight. It's a tale written over millions of years. Fossil evidence suggests that the ancestors of modern flying fish first appeared during the Miocene epoch, around 23 million years ago. These early versions likely had slightly larger fins than their relatives, which gave them a small advantage in leaping out of the water. Over countless generations, natural selection took over. Fish with longer fins, stronger tail muscles, and better balance were more successful at escaping predators. They survived longer, had more offspring, and passed on those favorable traits. Slowly but surely, this evolutionary pressure sculpted the perfect glider. It's a fantastic example of what we call convergent evolution. That's when different unrelated species independently evolve similar traits because they have to solve similar problems. Think about it. Flying fish developed wings to glide through the air, just like flying squirrels developed flaps of skin to glide between trees, or gliding lizards developed membranes to sail through the rainforest. The environment, in this case, the need to escape predators by becoming airborne, pushed evolution down a similar path, even though a fish and a squirrel couldn't be more different. But their evolution isn't just about flight mechanics. Flying fish have also adapted their entire biology and behavior to support this aerial lifestyle. Let's talk about their senses. Their eyes are specially adapted for a life spent on the boundary between water and air. They are flatter than those of most fish, allowing them to see clearly in both mediums. This is critical. They need to spot predators lurking below the surface before they launch, but they also need to be aware of airborne threats, like seabirds, waiting to snatch them from above. Their eyes give them a 360-degree danger assessment, enabling those split-second decisions that mean the difference between life and death. Their reproductive strategy is also perfectly tuned to their environment. Most flying fish species lay their eggs on floating objects near the surface, like seaweed, debris, or sargassum mats. The eggs have sticky filaments that help them cling to these floating nurseries. This keeps the eggs and the newly hatched fry in the sunlit upper layers of the ocean, where there's plenty of plankton to eat. By staying near the surface, the young fish are also in the perfect position to start practicing their gliding escapes as soon as they reach big enough. It's a strategy that ensures the next generation is ready to take to the skies. And like many fish, they understand their safety in numbers. Flying fish are often found in large schools. This schooling behavior offers multiple survival benefits. When a predator attacks, it's not just one fish launching into the air, it's dozens, or even hundreds, exploding from the surface in every direction. This creates a dazzling, chaotic spectacle that can confuse and disorient a predator. It becomes much harder for a tuna or a dolphin to single out one target when the air is suddenly filled with silvery gliding bodies. It's a coordinated, mass aerial escape that is one of the most incredible sights in the natural world. The impact of flying fish extends beyond their own survival. They are a vital part of the marine food web. As prey, they are a crucial food source for a wide range of larger animals. From the predators, they try to escape underwater to the seabirds that hunt them from above. Their role in the ecosystem highlights the delicate balance of predator-prey relationships in the open ocean. In some cultures, flying fish are also important to humans. In places like Barbados, which is often called the land of the flying fish, and in parts of Asia, they are a significant part of the local cuisine and economy. Fishermen have developed unique techniques to catch these agile creatures, and their presence is deeply woven into the cultural fabric of these coastal communities. Today, scientists continue to be fascinated by flying fish. By studying their biomechanics, researchers can learn more about the principles of aerodynamics and gliding. This knowledge can even inspire new designs in technology, like more efficient drones or underwater vehicles. Studying their genetics and evolutionary history helps us piece together a clearer picture of how life adapts and innovates in response to environmental pressures. They are a living laboratory of natural selection in action. So to wrap it all up, the evolution of the flying fish is a truly compelling narrative of innovation and resilience. Faced with the constant threat of being eaten, they didn't just get faster or better at hiding. They evolved a completely new dimension of escape, conquering the air in a way that no other fish has managed. From their torpedo-shaped bodies and wing-like fins to their specialized eyes and clever reproductive habits, every aspect of their being is a testament to the creative power of evolution. Their journey from the ocean depths to gliding above the waves is a powerful reminder that nature is full of extraordinary solutions to the challenges of survival. They show us that evolution isn't just a grim fight for existence. It's a process of boundless creativity and adaptation. The flying fish is not just a fish that jumps, it is a symbol of nature's ingenuity and the incredible possibilities that can emerge when life is pushed to its limits. Thanks so much for joining me on this journey into the world of flying fish. If you found this as fascinating as I do, make sure to hit that like button. And if you haven't already, please subscribe and turn on notifications so you don't miss our next deep dive. Let me know in the comments what other incredible animal adaptations you'd like to see covered. See you in the next video.